What's up? What's up? It's your man, Jimmy Chan. All right, so we're talking about real zeros of polynomial functions. So the remainder theorem. So what it's saying is that suppose f of x is a polynomial function. If f of x divided by x minus c, then the remainder is the same as taking the f of this c here. So these two c's are exactly the same, okay? So I don't want you guys to think these are different. They're exactly the same. So what is they trying to tell me is this, is that, okay, so it says divide by x minus 4. So typically I would say, okay, x minus 4 is equal, I'm sorry, x plus 4 is equal to 0. So x would equal to negative 4, right? All right, so that would be considered my so-called c. Okay, so what I would do is, instead of doing long division here, right, even though it's a divide, what I'm going to do is I'm just going to find f of that negative 4. Okay, so again, since this says it's a 4 plus 4, that means the c is negative 4. Okay, so let's go ahead and plug that in. So I'm going to have is equal to negative 4 to the third minus 5 times negative 4 squared minus 6. So this is going to equal to negative 64 minus 80 minus 6, because over here, negative 4 squared is a positive 16 times negative 5 is going to be negative 80. And this is going to give me a negative 150. So since f of negative 4 is negative 150, that means my remainder is going to be negative 150 if I was to divide these two in the long division. And remember, when we did long division, we said, well, this is over that x plus 4 when we did the division. Okay. However, this is talking about something totally different. Since the remainder is not equal to 0, that means that x plus 4 is not oopsies. You know what? It's okay. Let's do that. Is not a factor of x to the third minus 5x squared minus 6. Okay, so that part is very important to know. All right, so let me do this. All right, so unless the remainder is 0, then is a factor. But if not, then this is not a factor of this polynomial. Okay? All right. Let's see. The factor theorem says if f of c is equal to 0, then x minus c is a factor. If x minus c is a factor of f of x, then f of c is equal to 0. Okay? So here's the thing. If I was to look at this and it says, I got to determine whether this function has a factor of this. Okay, so a couple of things I can do. One is that if I have x minus 2 is equal to 0, then x is equal to 2. So what I can do is say, okay, I want to find f of 2. Well, f of 2 would be 2 to the third minus 2 times 2 squared plus 3 times 2 minus 6. So 2, 2, and 2. And let me see what that equals to. This is what? 8 minus 8 plus 6 minus 6. So that is equal to 0. So f of 2 is equal to 0. So that means, what does this mean? That x minus 2 is a factor of f of x equals to x to the third minus 2x squared plus 3x minus 6. Okay? All right. So with that being said, then what I want to do is, the question is, how do I break that down? And the way I would break that down is to say, okay, so now that I've done this and found that the remainder is 0, so that means this is a factor, now I'm going to have to do the long division to find the other zeros, right? So now I got to do, okay, I got x minus 2. I got x to the third minus 2x squared plus 3x minus 6. Then I ask myself, how many times does x go into x to the third? Right? I already know that this is going to be the remainder of 0, so it's going to come out perfectly. So I know it's x squared times, and when I multiply, x squared times x gives me x to the third. X squared minus 2x gives me a negative 2x squared. So I'll flip the signs and add, and I'll get 0. Since this is 2 terms, I got to bring down the other 2 terms. Which is my 3x and minus 6. Then I ask myself, how many times does x go into 3x? And it's going to be 3 times, positive 3 times. So I'll multiply 3 times x gives me 3x. 3 times negative 2 gives me a negative 6. I flip the signs and add, and I get 0. So I know my remainder is 0, so now I see my other factor. So what this is telling me is that, let me do this here. So what is this whole thing telling me? It's telling me that x cubed minus 2x squared plus 3x minus 6 is the same as x minus 2 times x squared plus 3. Okay? Now, with that being said, if I was to look for 0, so again, now I found my factors, right? So let me write this down. These are factors of this. Okay, so these are factors of that. Now, what if I was looking for 0? Then what I would do is say, okay, I know that x minus 2 times x squared plus 3 has to equal to 0, right? Because 0 means x-intercepts. So I would say, well, x minus 2 equals 0 and x squared plus 3 equal to 0. Well, the x would equal to 2, so there's a 0 right there. How about the x squared plus 3? Well, if I said x squared plus 3 equals 0, I'll say x squared is equal to negative 3. That means x is going to equal to plus or minus the square root of 3, which means that x is going to equal to forgot the negative. Need to remember the negative. So I got positive I square root of 3 and negative I square root of 3. Okay, so look at how many zeros I have. I got 1, 2, 3. But I should already know that I have 3 zeros. Why? Because the power here, the degree, is 3, right? So again, let me go and summarize this here. So f of x equals to x to the third minus 2x squared plus 3x minus 6 has a degree of 3. What does that mean? That means there's 2 terms, you're right, but it also means that there is 3 zeros. So in this case, what's my zeros? It's going to be at 2, at I square root of 3, and at negative I square root of 3. Okay? So notice how my factors are here, but yet I got this here. All right? So let's go from there. Now, just so you guys know as well, this right here, actually I shouldn't circle that one, I should circle this one here. So when we do long division here, guys, this right here, okay, I guess I want a parallelogram. This right here this is called a depressed equation. Okay, this is called the depressed equation. So anytime you do long division, whatever the result is with the remainder of 0 would be your depressed equation, which means it went from a third power down to a second power, which most of the time, if it's to the second power, that means we have a quadratic, which we then can find the rest of the zeros. Okay, as long as we're given 1 with a cube, we can find the rest once we do the long division. All right, and there you go. All right, so let's continue on here. Let's see. So what's a depressed equation? Well, now you know, right? A depressed equation is that thing right there. So we don't need that anymore. All right, so let's take a look at this. So we talked about this as well. This says a polynomial function cannot have more real zeros than its degree, right? So we talked about how this degree was a 3, so there's 3 zeros, and I can't have more than 3 zeros, and I have 3 zeros right here. Okay? Excellent. What does this one say? All right, this one says how to find the rational real zeros, right? So it talks about this right here. So let's go ahead and use this as an example. So to find potential rational zeros, what I have to do is this. I have to put this in standard form, meaning highest power to lowest power. Then I have to take, actually, let me just do it this way. And this, right? So I got to take the factors of the constant, put it over the factors of the lead coefficient. I got to find the factors of those. So the factors of 4, so I got to find factors of 4. So those are going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4. Those are all factors of 4. Then I have to find factors of 3, which is plus or minus 1, plus or minus 3. Come on. Okay, so I have to put this over each other as a ratio, and I got to do every combination. So that means I have to do So I have that one. How do I want to do this? What's the best way of doing this? And there's going to be more. You're wondering what the heck I'm doing right now. Okay. Nope, I don't need that many more. I don't know why I did that many of them. Okay, so every possible combination. So 1 with 1, 2 with 1, 4 with 1, 1 with 3, 2 with 3, and 4 with 3. Okay, so that means if I was to look at this, so this is every possible combination there are. So what do I have? If I was to do this out, it would be plus or minus 1, plus or minus 2, plus or minus 4. Plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. So those are all the possibilities that I could have. And is that going to go? Nope, I'm good. Right? Those are all the possibilities that could happen. Now everything else looks dwarfed with that 4/3. So let's make it bigger. There we go. All right. So those are all the possible ones. Okay. So then what you should do is say, okay, I'm going to find the f of 1 and see if that's going to equal to 0. Then find f of -1 and see if that equals to 0. Find f of 2 and see if that's equal to 0. So once I find one, then I'm good to go. Okay. Then I can go, okay, so if f of f minus 1 is equal to 0, then I know that one of the factors is going to be x plus 1. If f of 1 is equal to 0, then I know one of the factors is x minus 1. Okay? So that's what I'm supposed to do. However, if your professor is nice enough, what they will say is, go ahead and graph this and see where one of the zeros are. Okay? So let's go ahead and, if I can remember, I'll plug this in. Okay, so let me go in test mode and get rid of those, and go ahead and plug that in, and that is, what does that say? 3x to the third minus 5x squared minus 4x plus 4. Okay, so over here I see that it crosses 2, right? I see it crosses 2, so I'll go back here. Actually, let me do it this way. So let me do it here, and so I just take this picture right here. Let me crop it. And copy it. Let's bring it over here and paste it. Okay. So here in the graph, I see 0 at x equals 2. So that means one of my factors is x minus 2. Okay? So once I have that, then what I want to do from there is then do the long division. Time for long division. So I got my x minus 2. And I have 3x to the third minus 5x squared minus 4x plus 4. How many times does x go into 3x to the third? That would be 3x squared times. Then I got to multiply to both. And I'm going to get a 3x to the third minus 6x squared. I have to flip the signs and add. I'm going to be left with x squared, and I've got to bring down the next thing, which is minus 4x. Ask myself, how many times does x go into x squared? It's going to be positive x times, and then I have to multiply. All right? And I'm going to get an x squared minus 2x. Flip the signs and add. And I'm going to get a negative 2x. And then I got to bring down the next one, which is plus 4. Then I ask myself, how many times does x go into negative 2x? And that's going to be what? Negative 2 times. Then I have to multiply. And I'm going to get a negative 2x plus 4. Flip the signs and add. And no surprise, my remainder is 0. Okay? So which tells me that 3x to the third minus 5x squared minus 4x plus 4 breaks down to x minus 2, and this depressed equation of 3x squared plus x minus 2. Okay? So I have one of the factors, and I can deal with this part right here. Question is, can I factor this, right? So let's see. If I was to factor this, I know it's going to be 3x and x. It's either going to be a 2 and 1 or 1 and 2. Well, my outer, my inner is going to be 6 and 1, which is not going to give me a 1. If I do 2 and 1, my outer gives me a 3, my inner gives me, and let's see here. If to get 1, my outer gives me 3, so that has to be positive, my inner has to be negative, right? So again, 3x squared, got it. This is my last, right? That gives me negative 2, good. My outer gives me a 3x. Inner gives me a negative 2x, which adds up to a 1x, so it is factorable. So there are all my factors, right? So if I was to set it equal to 0 to find my zeros, right, then I would do x minus 2 is equal to 0. 3x minus 2 is equal to 0. And x plus 1 is equal to 0. So my zeros are going to be at x equals 2, x equals 2/3, and x equals negative 1. So that's where my zeros would be. All right, so I have found my real zeros. Now, the question is, what if this wasn't factorable, right? That's your question as you're going through this video, going, wait, what if I don't want to do the AC method? What if I don't want to factor this? What can I do? Well, remember, when you take this here, and say that this is equal to 0, right? When you guys do that, you guys can do the quadratic formula, right? A is equal to 3, B is equal to 1, and C is equal to negative 2. You can go right into the quadratic formula. and work everything out. And you'll get these two as your results. Okay? So do you have to factor? No. But if it's factorable, it's probably quicker to do so, but you don't necessarily have to. And I believe that is the end of the lesson. So I hope everything helps. If there's any questions, please let me know. See ya. Bye.